I'm going to show you how to compute the inductance of a conductive ring. So we're going to create a new project, and we first need to create the geometry. So the ring, it has a radius of 4 millimeters, and the wire has a radius of 0.1 millimeter. Then we construct an airbox around it with a size of 20 millimeters. That's all we need for the geometry. So if we zoom in, we can actually see our airbox and inside the conductive ring. Then we need to define our materials. We're going to choose air for the airbox and select the volume corresponding to it. And we're going to choose copper for the ring, and also going to select the volume of the ring. That's all the regions that we have, and now we can continue to define the physics. We're going to use an H5 formulation, so we're going to take phi harmonic, and the phi formulation is going to be used for air region, and then we're also going to take H harmonic, and this one's going to be applied for the copper region. We need to set the coupling, and we need to set a constraint on the walls of the airbox. So we're going to select all surfaces but our ring and set them to 0 ampere. And then we're going to set a current source on the ring. So we're going to take this curve and set it to a current of amplitude 1. Now we can also see with the arrows, we can see the direction of the current flowing. We are already done with that, and then we can set up our simulation. It's harmonic using both physics. We'll use 50 Hz as frequency, and we're going to run it on 4 nodes. For the mesh, we need expert mesh settings with a scale factor of 0.1 and a curvature enhancement of 50. We can already start creating the mesh, and we can add 2 outputs, so the magnetic flux density and the current density only in the copper region, because it's only defined in the copper region. So that's going to be it, and if meshing is done, we can start running our simulation. If we want to know our inductance and we want to print it out, we can edit that in the script. So we're just going to add some lines in the end. We can compute our magnetic energy by integrating over the product of V times H and multiply it by 1/2, and we can from that gain the inductance by multiplying it by 2 and then dividing by the maximum current squared. And we'll print that out in our log file. Now we wait for the meshing to finish. Now the meshing has finished. One thing that we could additionally do to speed up our simulation and reduce the number of degrees of freedom, we could change in the script the order of the phi formulation from 2 to 1, so that it is just 1 order higher than the one of the H formulation. And now we can start our simulation. So it is still downloading the results, but we can already take a look at the log file and the printout. So we can see that computing it took 106 seconds. We have a result for the magnetic energy, and we have a result for the inductance. And with analytical formulas, we also receive inductance in that range with a 1.5% margin. So the analytical one is 2.02 times 10 to the power of -8.